Most bearings live or die by their lubricant, lose the oil film and the metal galls, overheats, and seizes. But some machines run where oil cannot go. Inside an acid pump, a food line, or a motor shaft carrying stray current. A full silicon carbide bearing runs where that oil cannot, rings, balls, and races all ceramic, turning smoothly without grease, without rusting, and without passing a spark from shaft to housing. Because every load-bearing part is silicon carbide, the whole bearing is chemically inert. It turns in acids, alkalis, and seawater that would corrode a steel bearing into a locked lump of rust. The fluid the machine handles can wash straight through the bearing without harming it. The material carries no iron and no free electrons, so the bearing neither responds to a magnetic field nor conducts a current across its rings. And its extreme hardness lets the raceways resist the wear and the embedded debris that would pit a softer steel surface. Silicon carbide is hard, smooth, and light, so the balls roll with low friction and generate little heat, and the rings barely change dimension as the temperature climbs. That combination, inert, insulating, non-magnetic, and dimensionally steady, is what a full ceramic bearing offers that a steel one cannot. How does a bearing run without grease? Steel needs an oil film because two metal surfaces cold weld and tear where they touch. Silicon carbide is hard, smooth, and chemically unreactive, so its surfaces slide and roll with very little adhesion. And in a pump, the liquid being handled is enough to carry away the small heat that remains. The bearing is lubricated by the process itself. The second trick is electrical. In a motor driven by a variable frequency drive, stray shaft currents look for a path to ground. And in a steel bearing they arc through the thin oil film, burning tiny craters that grow into a washboard pattern called fluting. Because silicon carbide does not conduct, a full ceramic bearing simply blocks that path, so the current never reaches the raceway to damage it. Put the two together and the bearing solves as a system what steel needs three separate fixes for. It lubricates itself through the process fluid, it isolates the shaft electrically, and it resists the corrosion that would attack the raceway, all in a single component. Full ceramic bearings follow the same boundary dimensions as their steel counterparts. A 6000 series deep groove bearing, for instance, carries a bore, an outer diameter, and a width. The popular 6000 measuring 10 by 26 by 8 mm, and any bearing built to that standard interchanges directly with the steel one it replaces. Sizes span the standard range, with bores from around 10 mm up to 180 across the common series. Beyond the catalog, the cage material, internal clearance, precision grade, and ring geometry are matched to the shaft and the fluid. So a corrosive or dry running duty gets a bearing built to the exact seat the steel version occupied. Inside a sealless or magnetic drive chemical pump, the shaft has no external oil supply. The bearing sits submerged in the very liquid being pumped, and that liquid is its only lubricant. A full silicon carbide bearing is built for exactly this. It runs on the process fluid, resists the acid or solvent flowing through it, and needs no seal to keep oil in or chemical out. Because it is non-magnetic, it also sits undisturbed in the rotating magnetic field that drives the pump, and because it insulates, no stray current pits its raceways. Pulled after long service, the raceways come out clean and unworn where a steel bearing would have corroded, fluted, or seized for lack of oil. The pump stays leak-free because there is no seal to leak, and it runs longer between overhauls because the bearing needs no lubrication to maintain. Self-sufficiently, one ceramic bearing removes the oil, the seal, and the corrosion from the problem at once, turning quietly at the heart of a pump that handles what steel cannot.